Okay, good morning all of you. We are discussing about some important concept under Konnurs equations. So already we done electrode potential, EMF of the cell and equilibrium constant. One more is pending for us is nothing but delta G naught. Delta G naught constant. So for this also we are getting one formula. Actually delta G is equals to minus NF E cell. Delta G is equals to minus NF E cell. So change in Gibbs free energy is equals to minus N. N means number of transport electron whether in oxidation or reduction, Faraday and EMF of this cell. But I am taking at standard condition. At the standard condition. You know very well what is the meaning of standard condition. You have to take room temperature, you have to maintain 1 bar pressure, you have to take whole concentration should be 1 molar. Then EMF for the cell is standard. So automatically standard condition means what happening? Delta G is becoming like delta G naught and EMF of the cell is becoming like standard EMF of the cell. Yes or no? Can we substitute this in this formula? Yes. Delta G naught is equals to minus NF E naught cell. Is there any problem? No, this is normal at any case, but this is at standard. Okay, but already we know E naught cell from equilibrium constant. From equilibrium constant, we have E naught cell. Yes or no? So what is the E naught cell from equilibrium constant? Standard EMF of this cell is equals to 0.059 by n into log Kc. Can we substitute this one in this one? Yes, at this place of E naught. Okay, then we can do it. Standard free energy change is equals to minus NF. Instead of E naught cell, we can write 0.059 by n into log Kc. But I want to simplify this formula. You know very well 0.059. Instead of which one we written this value? Instead of which values we written this whole value? 2.303 into RT by F. Yes or no? At electrode potential initially we done this one. So instead of 0.059 can we write this value? Yes, right. Then what is coming? Delta G naught is equals to minus NF into 0.059 means 2.303 into RT by N and F. NF into log Kc. Some common terms is there. NF and NF is cancelled together. So finally we are getting standard free energy change is equals to minus 2.303 into RT into log Kc. This is the formula we are using. And we can change this formula into another one also. How is this one? 2.303 into log. Can we write ln to the base e? So also we can write this one as delta G naught is equals to minus RT into ln of Kc. ln means to the base e, log means to the base 10. That's the variation. So finally we got some formulas here. All of you understood. So once again I will write all the formulas at one place. According to that one we can solve the problems. The first formula under Nernst, electrode potential is equals to standard electrode potential plus 0.059 by n into log concentrations of the products ions by concentration of the reactant ions. Why I am using ions only? Yes, otherwise we are getting solids, liquids means we are getting its values will be remains constant or 1. And one more formula, EMF of this cell is equals to standard EMF of this cell minus 0.059 by n into electrode potential. No, we are taking only metal ions. Yes or no? Metal ions only. Standard EMF of the cell is 0.059 by n into log concentrations of the products ions by concentration of the reactant ions. Is it clear? And one more formula. What is that one? Equilibrium constant. What is equilibrium constant? standard EMF for this cell is equals to 0.059 by n into log. Instead of that one we can write Kc. At equilibrium position, what happening? Rate of forward means oxidation is equals to reduction. Then cathode potential is equals to anode potential. Then difference is becoming 0. So here E cell will become 0. Is simplified. Fourth formula, delta G naught is equals to minus 2.303 into RT into log Kc. This formula. From this we can tell one important point. Electrode potential values is always directly proportional to concentrations of the solutions. Are you getting or no? Yes. This is the information from this one, and based on this concept we will see some problems. Later we will go to in further concept. Just you try to work out. I will give some questions to you. Write the Nageswara equation for the Daniel cell. Already we done. No? Otherwise, once again write down. Write the first question. Write the Nageswara equation for the Daniel cell. Means EMF of this cell for Daniel cell equation. Formula for EMF of this cell for the Daniel cell. What is the Daniel cell reaction? You know very well. Zn solid plus Cu plus 2 aqueous into, means converting into Zn plus 2 aqueous, and copper is becoming solidified. I want EMF of second formula. EMF of this cell is equals to standard EMF of this cell plus or minus 0.059 by, yes, 2 Why? Because you already balanced. In oxidation, how many electron losing? 2 electron. In reduction also 2 electrons is consuming. That's why already balanced. No need to do any extra things here. So 2 into which one? Log of concentration of the products ions. Zn plus 2 ions by concentration of the Cu plus 2. That's it. Okay. Can I give one more? Write the equation for, means EMF of the cell equation for one of the cell reaction given. You see second one, Ni is converting into Ni plus 2 salt bridge and Ag plus into Ag. I explained this one also. Once you try to do this one, write down the EMF of this cell for this cell reaction. Yes, lot of meaning is there. Anybody? The left side part with respect to salt bridge, left side part is nothing but anode reaction. Anode reaction means oxidation or reduction? Oxidation. Very good. With respect to salt bridge, right side part is cathode. Cathode is generally involved in reduction. Okay, can we guess the whole cell reaction? Yes. What is the reactant here? Nickel. He is converting into which one? Ni plus 2. What is the reactant from cathode? Ag plus. Is becoming like Ag. Don't do blindly. Under oxidation, how many electron change is coming among? 2 electron. But under reduction, we are getting 1 electron change. Is it balanced? No. Should make it balanced. How? Yes. 2 Ag particles you have to take. Then we are getting 2 Ag. You know very well, nickel, pure solid, ion, aqueous medium, Ni plus 2, aqueous medium, silver, solid. Okay, we write the equation for EMF of this cell. EMF of this cell is equals to standard EMF of this cell minus 0.059 by 2. Yes, into log concentration of the product ions Ni plus 2 by concentration of Ag plus ions. That's it. No, yes, because the coefficient goes in its powers. Ag plus whole square. That point don't forget. 99% of students is doing mistake. They only nickel ions concentration by silver ion concentration. Should not, according to equilibrium concept, whatever coefficient is there directly goes in its powers. Okay, can I give some other? Write down EMF of this cell for this reaction. Aluminium converting into Al plus 3 salt bridge Ni plus 2 is converting into Ni. Good question. Lot of meaning is there. What is that one? Left side part LHS, anode, oxidation, yes or no? RHS, cathode, reduction. Yes, very clear. So can we expect a cell reaction? Combination of oxidation and reduction. What is the reactant? Aluminium is becoming like Al plus 3. What is the reactant from cathode? Ni plus 2 is becoming like Ni. Is it balanced? No. In one reaction, 3 electrons is releasing. In another reaction, 2 electrons is consuming. Or how can you balance it? Can we write 2 aluminium? Yes, 2 aluminium right down here. Can we take here 3 nickels, 3 nickels? Yes or no? Then it is a purely solid, aqueous. Ion means compulsory, aqueous medium, and pure neutral means solid. Balanced or no? Yes, each aluminium 3, 2 aluminiums, 6 electrons. What time you ask? I am getting no. This is each nickel is 2 electrons, but 3 nickels means 6 electrons. That's why I am telling whether oxidation or reduction after balancing we can change the electrons as n value. Okay, then EMF of this cell is equals to standard EMF of this cell minus 0.059 by 6 into log concentration of the products Al plus 3, that's it, no, square, by nickel concentration whole cube. That is very important. Yes? To try for one more question. So write down the EMF of the cell for one of the reaction given Zn into Zn plus 2 salt bridge HCl into H2 and platinum electrode. Yes. With respect to salt bridge left side, anode can be considered as oxidation over there. With respect to salt bridge right side, cathode, they are undergoing a reduction. Very clearly appearing. Platinum electrode, that is nothing but SHE, She, standard hydrogen electrode. Okay, compulsory here what happening? Zinc, converting into Zn plus 2. Very good. HCl is becoming H2. Indirectly HCl means H plus is becoming H2. Okay, that's when I read out. H plus is becoming like H2. Is it reduction? No, yes, 100%. Okay, is it balanced? No. So each zinc losing 2 electrons, but each hydrogen receiving 1 electron. That's why I have to take 2 H plus. Okay, either in oxidation 2 electron change, under reduction also 2 electron change. So we can write EMF of this cell is equals to standard EMF of this cell minus 0.059 by change in electrons 2 into log concentration of products per reactant, nothing but Zn plus 2 concentration by H plus ion concentration whole square. Yes? Yes, I am asking one more question, you do it. Just I will give you one equation. You try to solve it. Mg solid plus 2 Ag plus particles. Its concentration given 0.0001 molar and converting into Mg plus 2, and its concentration is 0.130 molar and plus 2 Ag. In this reaction, express the cell which the following reaction takes place. Means that's given, and how can we show the cell reaction? How can we show the cell reaction? Yes, very good. Which is undergoing oxidation of Mg to Mg plus 2. Oxidation is taking place at anode. Anode should be left side part, and this is reduction. Reduction should be takes place at cathode. Should be written on right hand side. Right, that's only. Mg, single vertical line, Mg plus 2, very good. The single vertical line represents physical state difference, and double vertical line salt bridge, and Ag plus is becoming like Ag. Yeah, no need to show coefficients, no need to write. Okay, if you want clearly, Mg+2 concentration is how much? 0.13 molar. Ag+ concentration how much? 0.0001 molar. I have to show like this. That's it. Now I am giving one of the question to try to do this one. Okay, a zinc rod dipped in a 0.095 molar solution of zinc sulfate. Zinc rod dipped in how much concentration? 0.095 molar of zinc sulfate solution at 298 kelvins. At 298 kelvins. And what is the electrode potential of a zinc rod? Electrode potential of zinc is how much is asking. Very simple question for competitive, just one mark, just one step. Zinc rod dipped in some concentration of the solution at room temperature. What is the electrode potential? Which formula we have to use? First formula. Yes. For the first formula, electrode potential of any electrode is equals to standard electrode potential of zinc plus 0.059 by n into log concentration of the zinc ions. That's it. Standard electrode potential of zinc value, you have to remember some values. Minus, very good, 0.76 volts plus 0.059 by n. Generally, n is what? Number of transport electron. How many electrons is transport? Zinc into Zn+2, 2 electron transfer. Zn into Zn+2, 2 electron transfer. That's only taken as n. 2 into log concentration of the zinc ions. This only na, because 1 mole of zinc giving 1 Zn+2, 1 sulfate ion. This many molar giving same. That's why concentration is nothing but 0.095 will be. To simplification, we have written something. Simplify this one as, for our convenience we can write it this one as 95 into 10 to the power of minus 3. Do it separately. Log 95 have to see. Around it will come 2 will come I think. Why? Because log 95 is nearer to 100. 100 means we can write it as 10 square. As simplified. Log 10 to the power of minus 3 will come 3 minus 3 log 10 to the base 10 will come minus 3. Minus 3 some value will be coming. You simplify all these things. So you are getting final answer minus point. Is it coming more than or less than? You are getting less than, it is nothing but minus 7 minus 0.79021 is coming. You check it later. You know logarithm how to see? Logarithm log 95. Log 95 how can you see? Yes, natural logarithm open it. For 95 how many digits will be there? 2 digits. 2 digits means minus 1. 1 point. For 95 you have to see 0. For 95 0 some value will be coming. You do it simplification all these things. Are all of you clear? How to see natural logarithm? So while seeing natural logarithm before decimal how many digits is there? 2 digits, not value. 2 digits minus 1, 1 point. For 95 0 you have to see right down here. You are getting some value. You simplify everything, you are getting. Yes. Come to one more question. Calculate the electrode potential of hydrogen. Calculate the electrode potential of hydrogen is the question mark. Contact with the solution pH is equals to. pH of solution is equals to, put model on it is 10, and the pressure is 1 atmosphere. Pressure is 1 atmosphere. Good question. From here we are getting one shortcut formula also. Later first you do it theory. So we have pH of acidic solution is 10, pressure is 1 atmosphere. Then what is the electrode potential of hydrogen? How can you do this one? Anyway, hydrogen is also electron. So what we can use? Electrode potential formula we can use. Electrode potential of hydrogen is equals to standard electrode potential of hydrogen plus 0.059 by N into log concentration of metal ions. Metal ions is nothing but here H plus ions. That's it. But directly we have H plus ion concentration? No. We have which value? pH value we have. How can you get from pH to H plus ion concentration? What is the formula for pH? pH is equals to negative logarithm of concentration of which particle? H plus ion particles. Okay, pH is equals to already given 10 is equals to minus of log H plus ion concentration. Good simplification. So both sides I am writing, multiplying with negative sign first. Then it is becoming log of H plus ion concentration is equals to minus 10. Now both sides I am writing 10 powers. 10 powers I am writing. Is there any problem? No. So again we have one more formula. Log A to the base A is equals to 1 will be coming. So this whole term is becoming 1. Then H plus ion concentration is coming 10 to the power of minus 10. Are you getting or no? So we are doing first of all pH formula. From there we are getting H plus ion concentration. First of all, what I did, both sides multiplied with negative sign. Later both sides I am writing 10 powers. A power log to the base A is becoming 1. Otherwise log A to the base A is also becoming 1. Then it will be coming 10 to the power of minus 10 molar. It will be. So how many electron transfer? That is important. So generally what happening? H plus particle will receives 1 electron is becoming like half H2. Yes or no? Generally acid means H plus particle will receives 1 electron is becoming like this. Then number of transport electron will be 1. Then electrode potential of hydrogen is equals to standard electrode potential of hydrogen will be very good 0 plus 0.059 by 1 into log of concentration of H plus ion will be how much amount? 10 to the power of minus. Good simplification. Log A power x. X log A. Yes or no? X log A means minus 10 into 0.059 into log 10 to the base 10 already is there 1. It is nothing but minus what is coming? 10 is nothing but we can write it as minus 0.59 volts into 10. Are you clear? This is a very simple. So from this, can we write one formula from pH and electrode potential? pH and electrode potential. We'll write one formula. What is the 10 value here? pH. Can we write one formula here? Okay. Reduction potential of any electrode. Reduction potential of any electrode is equals to minus of pH of that solution into 0.059. Yes. So reduction potential of any electrode, he given only pH value. Then minus of pH into 0.059. That's it. This is a very shortcut formula. No, he asked oxidation potential of electrode. Oxidation potential of electrode. What comes? Yes, opposite will come, that's it. pH into 0.059. Remember just once, another one is not required. Electrode standard reduction potential of any electrode is equals to minus of pH of solution into 0.059. No need to do entire process. All of it clear? But condition is what? N should be 1. Otherwise will not work out. So N should be 1. Silver into silver ions, otherwise Cu plus into Cu, like that only will be case. Write down here very carefully. Compulsory condition, and number of transport electrons should be 1. You see one more problem. If you have formulas thoroughly, and nothing for you this is. We can do it very easily. Just I will give you one more problem. This is only 5 marks question for you. You given N9 solid plus 2 Ag plus concentration 0.002 molar gives rise to N9 plus 2, concentration given as 0.16 molar plus 2 Ag solid. Even standard EMF for this cell is equals to 1.05 volts given. But what is asking? EMF for this cell is asking. EMF for this cell means E cell is asking. Once right, he given cell reaction and corresponding concentration, standard EMF for this cell given and asking normal EMF. 5 marks question this is. Very simple. Once you try to think it, I will explain otherwise. Okay, Nama. First write down related formula for this. Solution for this. EMF for this cell is equals to standard EMF for this cell minus, yes, very good, 0.059 by N into log concentration of the products ions by reactant ions. Okay, we want EMF for this cell, question mark leave it. Standard EMF for this cell already given 1.05 minus 0.059 by number of transport electron, how many? 2, already balance given, very easy. 2 into log concentration of the product ions means what? Nickel ions concentration by silver ions concentration whole square. Don't forget this one. Through simplification, 1.05 minus 0.059 by 2 into log Ni plus 2 ions means 0.16 by 0.002 whole square. You can do simplification. So write down here only. Otherwise write down one more step. 1.05 minus 0.059 by 2 into log. Can we write it? 0.16, leave it as it is. Denominator can we write it as 2 into 10 to the power of minus 3 whole square. Yes or no? Then 2 square, nothing but 4. 10 to the power of minus 3 whole square, 10 to the power of minus 6. Yes or no? Again we can do simplification. 4 here how many times? 0.04. Yes or no? 0.04 means we can make it as 4 into 10 to the power of minus 2. Write down that only. 4 into 10 to the power of minus 2 by 10 to the power of minus 6. Minus 6 comes up. Plus 6. Plus 6 minus 2. Plus 4 na. So finally we got here 4 into 10 to the power of 4. No need to see logarithm. Already we have log 2 value in chemical kinetics. So can we write it as, yes, very good amount. Log 4 into 10 to the power of 4 is there remaining as it is here. So 4 we can write it as 2 square. Yes or no? 2 square into 10 to the power of 4. Log AB formula we can be apply. Log AB. Log A plus log B. Then what is coming? 2 log 2 plus log 10 to the power of 4. Log 2 value 0.3010. Yes or no? Yes, no need to see. In chemical kinetics already direct value is there under half lifetime. 0.3010. Again log A power x. X log A. X log A. 4 log 10 to the base 10 becomes 4. Do simplification. No need to take much time for this one. What is coming? 1.05 minus 0.0295 plus. Sorry, that's no into whole. Then do it simplification whole. You will get some value. Or you understood? No need to actually like this only. Log 16 will come. We can make it as log 2 power 4. Like that log 32. Don't worry, logarithm is not there like that. How much is coming now?